All right, welcome back. So we're going to wrap up section 4.5. We have two more problems that are looking at some applications of all that we've learned about how we can modify our sine and cosine functions. So the first one says to find a and d for the function f of x equals a cosine of x plus d such that the graphs of f matches the figure. So they're giving us a drawing here, which I took from the book. This was number 65 from the text. And so we can kind of see some of the scaling that they've gotten here. So on the vertical axis, each dash is 1 unit. And on the horizontal, we can see we have pi over 2 here. Now, a couple of things to keep in mind. There's no horizontal shifts. We do have a vertical shift, and we got to worry about the amplitude. So let's start with the amplitude. Amplitude is usually pretty easy as long as we can kind of look at how high it goes from the top to the bottom. So we can see here that the highest point is at 3, and then the lowest point is at -1. So that entire distance is not the amplitude, it's just the whole range. So the amplitude is only half that. So we can see 1, 2, 3, 4. So 4 is the whole range from the top to the bottom. So we just want half of that, so the amplitude must be equal to 2. And so we can conclude that A should be 2. All right, so that is the first piece. Now the second piece is our shift. Now, if the amplitude was 2, where would we normally start if we are the cosine curve? So normally we would start at the highest point, which is 2. And then it would go down and then go down to -2. So what's happened? It's been shifted how much, which direction? And you can see if it normally started here and we're starting here, it's been shifted up 1. So up 1 means that d has to be equal to 1. So I don't know, I don't think they want you to write out the final function, but just in case, you could say, okay, so now I know that f of x equals 2 cosine x plus 1. Now remember, be careful, there's no parentheses around this. So if you wanted to be safe, you could then put the 1 in front, which is what they like to do sometimes to avoid that possible misinterpretation. So either way would be fine. All right, so that was the first one. The last one is very similar. Now we want to find a, b, and c for the function a sine of bx minus c such that the graph matches the figure. All right, so we got a little bit going on here, but we got our scaling. Each dash is 1 unit, and we can see the second dash here is pi. So if the second dash is pi, we should know this dash. We know this is pi over 2, and so on. So each dash is pi over 2 units. All right, let's start with the amplitude first. So what would be the amplitude in this case? Well, you can see the highest point gets up to 2, and the lowest point gets down to, looks like about -2. That's what it's supposed to be. So we can kind of conclude that our amplitude is 2. So we know that A is also 2. All right. Now for B and C, remember B is dealing with the period. So what can you tell me about the period from this? Now you can see that we're starting with a high point right here that's right in between pi over 2 and 0. So we should be able to conclude that at pi over 4 is where we're actually reaching that highest point. So if we shifted it back to the left a little bit and then kind of extrapolated, we should be able to figure out what our period is. So if we're started at 2 on the y-axis, normally we would drop down to pi over 2. So again, let's use our x's. So pi over 2, 2, At pi, we would be down to -2, and then back up, and then the fourth dash should be our period. So we can kind of see our period would be 2 pi. Helps if I spell it right. So if the period is 2 pi, what does that mean about value of b? That means b would have to be equal to 1, right? Now if you're not sure, just do a little algebraic equation. We got 2 pi over b is equal to 2 pi. Now we can just do a little cross multiplying and dividing, and we should be able to conclude that b equals 1. So there's our second variable, and so last but not least is our c. So remember, c helps with the phase shift, but be careful. Remember, we have to also take into account what b is. So we already know that b is equal to 1, so that's good. Now, we kind of already determined it from our graph here. It's a little hard to see it, but remember we said that it's starting at its highest point at pi over 4. So the shift is to the right, pi over 4. So if c over b equals pi over 4, then what, and we know that b is equal to 1, what should c be? So we can conclude that c should be pi over 4. And that wraps up our function. So f of x equals 2 times the sine of x minus pi over 4. So again, remember, minus means it shifted to the right. So that would be correct. All right, and that wraps up 4.5. So hopefully this gives a good overview of all those little nuances about graphing sines and cosines by hand. On a calculator it's much easier, but by hand it's nice to have little tricks. So hopefully it helped. Alrighty, stay tuned for the next video, which we jump into 4.8. So we are skipping a couple sections, but 4.8 is where stuff gets really good. So see you soon.